Welcome again to Learning Beyond. To continue with our structural standard drawing study, today we will see how to detail out the continuous slab. So continuous slab is also similar to beams as far as the behavior is concerned. So let's say, let me draw one continuous slab which is supported on the beams. For example, I will take over 2-span continuous slab. So continuous slabs may have more spans, more than 2, 3, 4, whatever. But the detailing is same. Let's say there are 3 beams and there is a slab supported on that. So for example, this is your slab and these are your beams. These are beams. And this is slab 1, slab 2, let's say. From behavior point of view, all of you know that if you draw the loading diagram, I will assume this at the center. Generally for analysis, we assume the supports are near the center. Let's say this is your loading diagram. There is a load on the slab, dead load, live load and all. And due to this, we will have a bending moment like this, right? So there is a continuity in the mid support. So we will have a support moment. And at the end, we generally assume simply support. Whenever a slab is resting on the beams, at the ends, we assume it simply supported, because if I assume the slab as a fixed slab, then there will be moment here. And that moment will transfer in this beam as a torsion. And we generally don't allow any torsion in the beams unnecessarily because of a brittle nature of the torsion. So I assume this as a simply supported at the ends, and in mid support, we have a continuity. So you can understand there is a moment here, hogging moment, let's say, there is a sagging moment here. There is a sagging moment. So the tension is here in this support zone, compression here. Then in this zone, we have a tension at the bottom, compression at the top. Again, tension at the bottom, compression at the top. So look at this. That means whenever there is a tension, we will provide a main steel there. So in slabs, generally we use bent up system. And in our simply supported session, we have already seen, we use the alternate bar bent up system. So let's say what I mean by that. So for this tension, we will provide AST. So it will be like this. Then from here, we will provide bent up like this. And it will go like this. So this is your bar. Assume your steel is, let's say T8 as per design. Let's say we require T8 at 150, for example, AST required for the moment. So it will be T8 at 300. Okay. And then we will provide more in this direction. Then this way, and it will go like this. This will also be 8 at 300. So the total AST at this zone will be T8 at 150 as per AST requirement. Then now as there is a continuity here, we need to extend this bar. So this will not stop here like simply supported, but it will go beyond in the other slab also. Okay, so this will be, let's say, continuation. Now for the other side of the slab also, same is the case. So we will have a bent up system like this. And then we also have this beam. This will be like this. Okay. So you can see at the mid support, this bar is continued in the next slab, and this blue color bar is continued in this right side slab. So we have a 8 at 150 at that zone. So how much I am getting here? Same 8 at 150 because of blue and red color bars, both 8 at 300, 8 at 300 means T8 at 150 as per AST requirement. So these are the details, and now we should know what is the location of this bent up. So as this is a end support and simply supported end, I can say assume this span as L1 for this slab and L2 for this slab. So this will be L1 by 7 due to end support, simply support. As this is a continuous end here, I will assume as per actually this is as per code L1 by 5. In the continuity zone, we take it as a L1 by 5. And at the end support, we take L1 by 7. Now this bar, so how much I should continue this into this slab? So this red color bar will go in this. From here to here, it will be L1 by 4. And from here to here, this blue color bar, L2 by 4. Then definitely there will be distribution bar. If this is a one-way continuous slab, then we will have only distribution green bars like this. Here also, and here also. As similarly for this slab. And if we have this two-way continuous system, then this green color bars will be main steel also, similar to this blue and red color bars. So this is the behavior of continuous slab and the steel detailing as per IS code. Generally, we send this kind of drawings to the site in the structural drawings. Now, next we will see the cantilever slab. Again, same as far as the behavior is concerned, like beams. Assume that there is a cantilever slab supported on the beams. This is a cantilever beam. Cantilever slabs supported on the beams. So analysis is similar to that beam. So there is a cantilever beam here, and there will be load on the slab, and we will have a bending moment diagram like this. Assume this as a simply supported, then we have a bending moment like this. So you understand that there is a tension at the top, compression at the bottom for cantilever full, and there is a backup also. You can see bending moment is getting transferred in the left side slab also. So there will be continuity. That's why we need to provide this reinforcement in the back beam also. And then there will be moment here. So tension here and compression at the top. So this is your hogging moment, we can say, and this is your sagging moment. Now, how should I detail? So the detailing is same. So this, we will continue this. So whatever is this, assume this as a L1 here to the right side and L2 to the left side. Okay. So there will be reinforcement for this moment, and it has to go back. And how much it has to go back? So from here to here, it will be L1, or see L1 means this, LD, whichever is maximum out of this, similar to beams. So this is your main steel. Then definitely, now in cantilever slabs, what we do, generally you can see that there is no reinforcement here. And if you don't provide any reinforcement in concrete, then there is a possibility of cracks. We know that it is a technically compression zone. Technically, it is not required any steel, but we need to provide for shrinkage cracks and other things. So generally what we do, we bend this steel again back. So some people bend this half bent up, we can say. So half bars will be bent back and half will be full. For example, I will show you what I mean to say. So let's say our requirement as per the design is, this steel requirement is, say T8 at 150. So how will I provide this T8 at 150? So here I will show I will provide this bar. Okay, here. This will be T8 at 300. And then I will also provide this bar like this bend back, similar to this. So this will be T8 at 300. So total will be T8 at 150 at the top, because I want steel at this zone T8 at 150. So this will be T8 at 150 and this will be T8 at 300. So you can see this alternate bar bend back. And many times I generally recommend, instead of this 8 at 300, make it 8 at 150 at the bottom also. Because due to say environmental effects, we see that there are cracks and deterioration in this zone. There is a corrosion in steel also. So it is better to have a more steel in this zone also, because this is generally cantilever is exposed to the weather. So I can recommend that you can just put this 8 at 150 till at the bottom also, like this. Okay, so this is the detailing of cantilever, and this back side is same as we have seen in the continuous beams. Yeah, so it will be bent up like this. You need to continue here. %50 bars, and then again here like this. So this is your detailing, and this part is same. L2 upon 7, then this one will be L2 upon 5. And this continuation also, from here to here, it will be L1 upon 4. So this is the detailing and distribution bars. Definitely there are there like this. Minimum steel as per code for distribution steel. Again, for this portion, we will have distribution bars here also. Okay, so that's it for the cantilever slab detailing. Now from next session, we will see the practical structural drawings, and I will show you the drawings. This is actually handwritten sketch. In that, we will show you the AutoCAD drawings and how the detailing drawings are given to the site. And there are many other things we will learn in that regarding the structural notes and so on. So for the time being, yes, we will stop here, and let's meet in the next session. Thank you all.